Good evening, everyone. I welcome you back to my YouTube channel, and presenting before you this wonderful tutorial is Hampeyo Kliman. So today we'll be looking at integrals, integrals of course, and particularly trigonometric integrals, and we're going to make everything simple. Now, to start with, we have been given the first question, which is saying we find the integral of cosine power 5 x dx. How do you go about solving this question? Well, it's very simple. The first thing that you must know is that if you have some integral of m multiplying n, m should have at least an even power, and n can have at least an odd power. So this is the concept we use. How do we apply this particular concept? Well, notice that cosine power 5x, cosine x to the power 5 can be broken to cosine 4x multiplied by cosine x dx. This can also be written as cosine x power 2 all over to the power 2 multiplied by cosine x dx. Notice that sine power 2x plus cosine to the power 2x equals 1. Therefore, cosine to the power 2x is equal to 1 minus sine power 2x. So this particular part is everything in the brackets, so we can do a replacement. Okay, so this is our replacement. Everything to the power 2, then cosine x dx. Now we can make u equal to this part, so u is going to equal sine power x, or let me just say sine x, so that du is going to equal to cosine x dx. We make dx the subject, so dx is going to equal to du over cosine x. So we can now get our du and put it where there is dx. Notice that this cosine and this cosine cancels, so we are going to have something like integral of 1 minus u to the power 2 like that, okay. From here, this can also be written as, we can now integrate everything. So now we can first of all expand this. So if we expand that, we're going to have 1 minus u power 2 minus u power 2 plus u to the power 4. So this is going to be 1 minus 2 u power 2 plus u power 4. Then if we integrate this, we are going to get u minus 1 over 3 2 u to the power 3 plus 1 over 4 u to the power, let me just say 1 over 5. So this is going to be 1 over 5 power 5. So remember that our u was cosine x. Sorry, it was sine x. Okay, we made u equal to sine x. So in this case, our u was sine x. So we are going to put sine x here minus 2 over 3 sine to the power 3 plus 1 over 5 1 over 5 sine to the power 5 plus some constancy. So this is just how you go about solving this particular question. All right. Okay. We shall use the same concept for the second part. So the second part, they are saying we integrate sine power 5 cosine x dx. So the first thing to do is to work out the odd power. We take it into an even power. So if we take it into an even power, we're going to have sine to the power 4x multiplied by sine x cosine x dx. Now notice that this can also be written as sine to the power 2x, everything to the power 2, then sine x cosine x dx. Now when we reach here, what then do we do? Remember the trig identity? This part can also be written as 1 minus sine power 2, sorry, this is cosine, so this is supposed to be cosine power 2x to the power 2, then cosine, sorry, supposed to be cosine x cosine x, then we have sine x dx. Now notice that we can let u equal to cosine x so that du can now equal to negative sine x dx. If we cancel both sides, we have sine x, we have sine x. So meaning our dx is going to equal du over sine x. So here where there is dx, we can put our du over negative sine x. This and that can cancel. The negative will be transferred here. Okay, so in other words, we can have our negative transferred here. There is no difference, it's just one and the same. Now this simply means that everywhere where there is cosine x, will replace with u, then du. Now if we do that, so if we do that, that simply means that we are okay. Let me just write this. So we have negative integral of, this is 1 minus u to the power 2, then u du. Okay, so we equated. All right, so our u is equal to cosine x. So when we reach here, what we do is this: we can expand. Okay, so let's try to expand this. So the concept is the same when expanding. So this is going to give us something like this: 1 minus 2u to the power 2 plus u to the power 4, everything multiplied by u. So we're going to get something like u minus 2u to the power 3 plus, and of course this is going to be u to the power 5 du. Now notice that if we integrate this, we're going to have something like this: minus, so this is going to be 1 over 2 u power 2, minus, it's going to be 2 over 4 u to the power 4, plus this is going to be 1 over 6 u to the power 6, plus some constant c. So remember that this negative is multiplying everything, so we're going to have negative 1 over 2. What was our u? It was cosine x, minus, this is going to be a plus. What was our u? It was cosine, so cosine 4x minus 1 over 6 cosine 6x plus some constant c. So this is how you solve this particular question. Okay, so if you can solve that, it means you can solve any other question including this. So if you solve this one, then you can send it on my account, and I'll be proud to see that students are really paying attention and they're concentrating and they know what they're doing. All right, we now get to solve this particular question. How about if you have been given the integral of a tangent? How do you go about solving it? Sorry, let me just clear my board. How do you go about solving this? Well, it's very simple. So if you have been given to solve the integral of tan x dx, the best way to go about this question is simply to, okay, well, this is just the same as sine x over cosine x dx. You can equate your u to cosine x so that your du can equal negative sine x dx. Okay, let me just put it somewhere here. So this means that we can now make dx the subject. Dx is going to equal du over negative sine x. So meaning this can also be written as sine x over u, then while there's dx we put our du over negative sine x. So that and that will go. We're going to have the integral of 1 over u. Remember that integral of 1 over u, the answer is just the natural log. So the negative is here, then plus some constant c. So therefore our final answer is negative ln of, this was supposed to be cosine x plus some constant c. So this is how simple this is. Now how about if the question was written like this? Okay, how about if the question was written like this? Can make it to be e. Let's say we have the integral of tan power 3 x dx. Well, the concept is the same. We can break this one down to tan to the power 2x and tan x dx. Notice that secant squared x is equal to tan x plus 1. Therefore, it's supposed to be tan squared x. Therefore, tan squared x is equal to 1 minus, okay, this is supposed to be 1 minus, well, am I writing the correct thing? Let me okay, so how is the trig identity supposed to be? Okay, so our 1 is supposed, okay, all right, let me just try to write this the correct way. So remember that the 1 is coming this side, so this is just the same as secant squared x minus 1 equal to tan squared x. So everything is just okay. So now we can now replace. So by replacing, we are going to put secant squared x minus 1, then we have our tan x dx here. Now notice that this tan is going to multiply everything, so we're going to have tan x secant squared x minus tan x. So from here, this can also be written as tan x secant squared x minus the integral of tan x. Now we have this particular part here. We can make we can make, let me just try to write that. So this is tan x secant squared x minus the integral of tan x. So we can make u equal to tan x, so that our du can equal secant squared x dx. So dx is going to equal du over secant squared x. So meaning I can put, while there is u, I can put, where there is tan, I can put u, then I have secant squared x, then du over secant squared x, du minus integral of tan x. So if I do that, this and that will cancel. So I'm going to have integral of u du minus, this is tan x dx. Now notice that this is just 1 over 2 u minus, now remember the integral of tan x, it was just 1, it was just negative the natural log of cosine x. So this is just the same. Remember that this was tan, so this is tan x plus natural log of cosine x plus some constant c. So this is just how you solve these questions, and if you find this video helpful, consider subscribing. Thank you so much.